Thank you for joining for this episode of the TechSpective podcast. I have with me for this episode two guests from Adobe Security. So if you guys want to introduce yourselves and give a little bit of background on what you do, and then we'll get into it. Who wants to go first?
I do, if that's okay with everybody. Hello, my name is Tiberiu Boros, and I'm a machine learning engineer for the SEC, the Security Coordination Center in Adobe. I am very passionate about machine learning in general, about natural language processing, spoken language processing, and I'm also very excited to see how machine learning applies to the realm of security. We also have a lot of machine learning driven projects that we previously worked on. Some of them are open source. So if anybody wants to see what we do for a living here at Adobe, the security team, you can check out our previous projects such as the Living of the Land classifier, the obfuscation detection tools that we open sourced, and also the one-stop anomaly shop project, just if you want to check them out. So, Radu?
Hello. As you already heard, my name is Radu, and I work closely with Tiberiu as a machine learning engineer intern, but I will start the full position from next year. I'm currently doing my master's degree in which I basically research a lot of machine learning stuff, most related to computer vision. And also here at Adobe, I'm involved with a lot of machine learning projects, including the one that we will talk about.
Awesome. All right. So let's go. Let's go there. I brought you guys on to talk about Project Sherlock. At least that's the kind of internal code name. So can you give me an overview of Project Sherlock and kind of explain how or why it came to be?
Okay. So in order to set things in stone, to actually explain what Project Sherlock is, it's a collection of tools. But the cool thing is that it leverages large language models in order to enable users to build their own AI assistants. So the interesting thing is that a team or an employee can have an AI assistant up and running in a Slack channel that can also use data. So the AI assistant can have access to data that the user or the team shares with the AI assistant. In order to better understand the current stage of the project, I can start with the beginning. So the initial problem was actually related to the volume of threat reports that was coming into our center, right? So you had a lot of threat reports. You don't have that much free time, and you want to get rid of these mundane tasks. So what you do, you try to automate the process. So we initially started looking into classical machine learning techniques like name entity recognition to actually extract and analyze key points of the threat reports and then have an analyst review them and so on and so forth. But in the same time, a new technique was emerging from the realm of large language models. So you have the large language models that are trained on huge amounts of data, right? Huge amounts of text, and they somehow retain a general knowledge of all of that text. Everyone tried ChatGPT or Llama or Mistral or any other large language model. The problem is that this generic data is not, you cannot apply it on specific data, right? So the simple idea that RAG, this is the technique, RAG is called Retrieval Augmented Generation, is proposing is that, okay, let's just use the reasoning capacity of the large language model and provide the context ourselves. So basically, if you have a lot of data, why not just extract the relevant information from that data and feed it into the prompt of the large language model so that the large language model actually learns on the new data with its current reasoning capacity. So this is why it's called retrieval augmented generation. You retrieve some data, you augment the prompts, and then you generate a response. This all came together during Garage Week. So Garage Week is an innovation week, is a week dedicated to innovation here at Adobe, in which we're encouraged to explore new projects. And during that week, we came up with a proof of concept that was basically a mini assistant that was able to analyze a threat report using retrieval augmented generation. It worked pretty well because we were able to get in a few lines the attack pattern described in that threat report that was actually 10 pages long. And not only the attack pattern, but information about the actors, information about the indicators of compromise, and so on and so forth. So it worked pretty good. And then a new question came up. If it works with one report, will it work in multiple reports? So we started exploring that part, trying to scale up what we already had, right? And the answer was yes, it worked with some minor improvements that we need to take care of. But then if it works with multiple threat intel reports, will it work with like just documents? And the answer was also yes. And because we had a lot of exposure during Garage Week, we had also a lot of people a lot of teams that were interested in what we were doing. And now an even more interesting question arises. So you have all of these teams that want to be part of the project. How can you design, let's say, a process that will enable those teams to onboard our project as fast as possible? So this is how we currently arrived at the present moment, in which you have the team that has data, wiki pages, documents, reports, documentation, so on and so forth. And in like 3 commands, will have its own personal assistant in a Slack channel that has access only to the data that they provide, right?
Mm-hmm. Well, and that actually is, and you've already hit on this or whatever, but like that is the key. Obviously we've spent all year talking about, I think we just hit the 1-year anniversary of the public release of ChatGPT. So we've spent all year talking about all these everyone has generative AI now. And everyone's doing large language models and that's great. And there's a lot of benefits, but one of the examples I've used in the past is like, it still comes down to the data set. Because I could have a very comprehensive, extensive, the very best database ever of like recipes and kitchen cooking information or whatever. But if I pose a cybersecurity question to it, I'm going to get crap results. So it's what data am I looking at, and am I asking the right questions for that data set?
Yep.
Yep.
So you like I said, you hit on it already in terms of like the way you guys within Project Sherlock are sort of limiting the data, or like selecting the data sources or whatever. So that's helpful and useful to be able to say, look, I'm specifically trying to figure out this incident, or I'm trying to figure out these threat reports. So let me just look at the data that's relevant to this thing and derive my results that way.
Yeah, so basically the large language model is in some sort of way capable to think, but let's put it to think on this particular data, right? So it learned how to think on a lot of data, a lot of noise, a lot of data sets, but let's make it more particular to this data.
Okay.
Yes.
Well, so and again, I think you might have done this a little bit already, but can you just walk me through sort of what's a typical use case? Like how is someone inside Adobe Security or Adobe using this? How is it saving them time and resources?
Okay, so a typical use case would be like, as I've mentioned earlier, a team that has, I don't know, a lot of wiki pages that it's hard to search through, and they came with those wiki pages or documents to us, and we set up a Slack channel in which they interact with their own data and they better understand them. And okay, and like this is the general use case of Project Sherlock. Again, you have your own data and you interact with it and you take action upon it and you get the model's insight on all of those scrambled text pieces, right? More related to security, right now we have some use cases with sales security engagement, in which we have a lot of standards and product security white papers, and we set up a channel in which the bot can actually respond based on those security white papers. And it's pretty interesting because a lot of those questions were previously said to be difficult, but the model actually found its way within all of those vast amount of data. We also have a more security inclined channel for threat hunting, in which we've ingested a lot of threat reports. So there you can actually interact with the bot and ask about certain threat actors, certain threat patterns. You can assess for like a country what is the risk and so on and so forth. And the cool thing about working on something that is, let's say, pretty recent in terms of technology used, is that it sparks new ideas. So while we were building our infrastructure that can hold these multiple use cases, we also built an API. And by building an API, a lot of other engineers from security started to consume that API and get new use cases, right? Right now, we also have like a Chrome extension and integration with Phantom. So for a SOC analyst, you can better understand like scrambled and obfuscated code, right? You can have the LLM help you with analysis on that particular piece.
I would, if everybody's okay with that, I would also like to build on what Radu said a little bit about Project Sherlock. Because I mean, I know everybody noticed that those are kind of pretty much scenarios where you have a knowledge base and you answer questions from it. But the thing is that, I mean, if you think about security, the first thing that comes to mind, whether we are talking about incident response, SOC, threat hunting, or anything else, is that time is of the essence. Because that's true for any particular field. But I mean, there are situations here where minutes matter. So if we would like to state like a primary goal for Project Sherlock is, Project Sherlock aims to provide that assistive technology that would enable the users, the consumers, to reduce their workload and increase their efficiency, which is kind of normal for, this type of the way large language models have been used in the past. But the thing is, how we do this is that we from the security point of view, because we have other use cases that are thriving right now inside Adobe, but from the security use cases, we target a couple of things. So ingestion of threat intel reports to be able to process them, respond questions from them, and spot trends. Be able to prioritize threat hunting tickets. And how do we do that? For instance, how would you select your next ticket in the queue? And I know obviously the lazy answer would be that you select whichever seems easier, you just do it and you look good for your manager. And I'm just kidding here. I mean, we don't do that at all. But I'm thinking more on the lines of being able to ask Project Sherlock, what are the current trends in the threat landscape? Because I want to know what would most likely impact my infrastructure based on the attacker patterns and what's going on in this, in the security realm, like in the last 2 weeks or 3 weeks, basically threat intelligence. If something is going to target something that I'm relying on, a third party or a vendor or something like that, I might want to know that so I can start my own investigation to see if something got compromised. And finally, the last, basic tool of Sherlock, because at some point the toil involved in switching between several pages, providers opening a new window, logging in and clicking a button and so on becomes like toil work that is against the productivity. We want a decent level of integration with external services and a decent level of automation, like be able to query structured data sources like Splunk, Caspian, SQL, or create your typical Jira ticket.
Okay. Yeah, I mean, a lot of what you described, and I saw this term referenced in some of the stuff I read about Project Sherlock, but it's this concept of the intelligent intermediary. It's almost like having Project Sherlock as, if I'm a security analyst, Project Sherlock is like having like my own personal intern, where I just say, here, I need you to look at everything, go through it all, figure out what's relevant, give me the context, and then just boil it down to a top 5 report for me that says, hey, start here. This is the most important thing. Go do this. It's just that Project Sherlock, as the intelligent intermediary, is able to do that in a matter of seconds, as opposed to me giving all that to a human intern and hoping for a result by the end of the week.
Yeah, that's pretty much it. It also, we try to retrieve a lot of facts around the answers that we create, so that you can do your own fact checking.
Right.
So we don't introduce noise.
Which is I wasn't aware of that, but that I think is very important. Because one of the issues I've had when I go and play around with things like ChatGPT or Google Bard or whatever is, I ask a question, I get a response. The response seems true, it seems authoritative, but it's not real good at citing, like, well, where did you get that answer? And and I can't fully trust the answer if I can't verify it in some way. So it's like, yes, by all means, do what you do, go, process everything through this large language model and give me a result, but also give me some links, give me some sources, give me something that tells me that lets me fact check that myself to make sure it's true before I just take it as gospel.
Yeah, and I have an even funnier story with this type of LLMs. When I was doing some research and was trying to find some related papers, they were actually spitting up the title of the paper, the authors, and even the abstract. And when I was searching for that particular paper, it didn't show up anywhere. And I was like, where did you get that paper from? I invented it.
So I did that myself. And I understand, ChatGPT is an ongoing sort of open beta, like it changes constantly. So this was months ago, but like back in the summer at some point, I was playing around with ChatGPT and I asked it to, write an article on this topic. And I gave it a bunch of links I gave it a few different links for references, but I said, but I was like, but I want it to be authoritative. Like I want you to actually quote sources and individuals. So it did. And if you just read the article, you'd be like, wow, this is pretty good. It seemed factually true. It had links to external news sources to support certain things. It had literal, in quotes from like known people, right? And so I went and Googled, like I took the quote and I went and Googled it. I'm like, that quote doesn't exist. That person never said that thing. And then I looked and I clicked on the links, and all the links were 404s, even though they went to like NBC News and Reuters, and like they look like legitimate URLs, but they were all 404s because ChatGPT literally just invented all of that stuff. It said, "Oh, well, you wanted links and sources, so I gave you links and sources." And I was like, "No, that's not how links and sources work, ChatGPT."
Right. So in the early phases of the project, when we were presenting the whole concept of Project Sherlock to our management team, we had this time chart because it was really important for us. It was a part of the lessons learned. And the funny thing was that we spent 3 weeks writing the initial code to get the Project Sherlock up and running. And we spent 1 more month doing prompt engineering to keep it from hallucinating answers and basically lie to the user in plain sight.
Yeah, basically restricted to the context that you provide, and not just add things from.
As this evolves, though, as the concept of generative AI evolves, and as we get to what are they calling it? Artificial generalized intelligence or whatever, like
AGI.
In theory, right? AGI. Like in theory, I do want at some point for the AI to be able to think outside the box to some extent, to creatively give me a response. However, it still needs to be accurate and factual in some way, shape, or form. It can't just make stuff up. And that's I think the dividing line. It's like if I just limit it purely to, listen, all you can do is search the data I gave you and give me exact responses from the data I gave you. That's just glorified Google. It's like that. I can already do that. But so I do want it to. I want it to hit that next level, but it has to do so accurately in a way that's verifiably true.
That is a tricky subject, I guess, for everybody in the research community right now, and I think the road to getting to that point is unclear for everybody. I don't know anybody saying that they have the holy grail of on how to do that, like the magical solution is going to bring those the AGI and the LLMs and everything else to that point. But I mean, it's definitely going to be exciting to see how things develop in the future.
Yeah. Semi-related, but let's go back to one of the things that you talked about was the ability to pull unstructured data from various sources, Splunk, whatever. And it's obviously very easy if I start off with a database of, I know exactly what this database is. It's, my table is set up the way I want my table to be set up, so I know exactly what I'm looking for. It's a whole different thing if I just say, hey, here's a bunch of data. Here's a bunch of unstructured data. I don't know what it is. I don't know, whatever. So how to, basically, I guess it's kind of a two-part question. What kind of unstructured data does Project Sherlock handle most effectively? And then, and is there a process within Project Sherlock to sort of validate the, quality and relevance of that data?
So, the typical type of unstructured data that Project Sherlock ingests is natural written text, because those documents in natural language are unstructured data. I don't know if you are referring to something else like unstructured in the sense that you don't know exactly the schema, but you have some, attributes and values to it, or a typical format. But text is definitely an unstructured form, and it does pretty well with the text. Of course, talking about the what was the exact question again? How do we assure the relevance, or
just like the quality and relevance of data? Okay. that it's ingesting.
So given that we are use case driven, and every time we deploy Project Sherlock for a use case, we onboard some team's data. We do that together with them, so they make sure that the data is accurate, is up to date, and they are supposed to keep it up to date. And whenever something changes, just reingest that document or that set of documents into Sherlock and keep it relevant.
Okay.
So it doesn't go on its own to search data
right.
in the company's infrastructure.
Right. Which kind of goes back to the beginning of the conversation with having like a more refined data set from the start. Like, one of the challenges for something like ChatGPT is it's trying to use the internet at large as its data set. And it's like, well, that's very broad and 75% of it's wrong anyway. So that's a horrible place to start.
It's an understatement, the 75%. So.
Right. Well, and I had done an interview earlier this year where we were talking about it. They had asked me about my thoughts on generative AI in general and stuff, and I said, well, the problem for me with something like ChatGPT is there's a cognitive bias for most people that if I ask Google, if I ask ChatGPT a question and it gives me an answer, I assume the answer is true. Like, it's worded in a way that like is just stated as a fact. And so like most people don't dig in to like go find, most people wouldn't do what I did and go click on all the links and try to search the quote, because that article that it gave me was very convincing. So the problem is then somebody takes that article, they publish that article online as fact, and now you've poisoned the data set in a way that creates a downward spiral. Now, next time ChatGPT goes to look for that same answer, it goes, oh, look, I found this article. and it's just its own article that was wrong in the first place. And it's like, so it's like, it's a bad model. There has to be a way for, and I'm sure they're working on that, but like ChatGPT has to have a way to like somehow validate its own data, and in terms of quality and relevance, even when you're looking at the whole internet. One of the other things I saw when I was, kind of doing some background research on this was there was discussion of sort of multi-persona support within Project Sherlock. And so I was curious, how does Project Sherlock handle like different roles? Like how does it cater to, say, a security engineer versus a security analyst or whatever?
Okay, so as we mentioned earlier, there are different use cases, right? And different use cases will use different data. And you'll have multiple Slack channels, multiple Slack bots that will do different thing. So the multiple persona thing is that each one of those different assistants will have different prompts, different guidelines. Because if you have an assistant for a SOC analyst, it needs to behave differently. And by prompting the assistant to be someone else, like, hey, you are a SOC analyst assistant, you can do this and this and that, you can actually take the meaningful part of the LLM reasoning capacity, because it has like that broad perspective on stuff, and use it only directed into the realm of SOC analysts, right? And if you have, I don't know, like a channel when maybe you want to ask questions about Jenkins or some other technology, then you'll have the bot to assume the identity of someone that knows that stuff, because that way you actually tap into the brain of the large language model, right when where those, let's say, links between the tokens were made in the context of an engineer or something like that. Right, so you're basically trying to direct the reasoning into what you want.
Right, that makes sense. I've actually seen, again, it's an evolving topic, but I've seen people who are, the kind of the proclaimed prompt experts for ChatGPT or whatever, but like where I might just say, hey, here's the question. I've noticed that a lot of the prompts do start off that way. They're like, okay, you are an SEO expert that understands blah, blah, blah. Now give me this answer. And I guess, like you said, it kind of puts the LLM, puts the generative AI model in that mindset of, okay, let me consider this. Let me consider the data from that perspective.
Yeah, it basically makes the model be more attentive to the words that are related to that subject, right? Rather than just blindly search through all of that, to all of its knowledge. And it's pretty interesting because I've seen experiments in which they simulate multiple personas in the same prompt, right? So you have a prompt in which you instruct the model to behave as also a CEO and a CTO and have conversations and then get to an answer. And it's a pretty interesting direction of research.
Okay. As far as like, you've got this, you have the data sources. I don't know if that data is being centralized in some way, but like basically how does Project Sherlock mitigate introducing noise into the system or getting sort of, I guess muddying the data waters?
So, I mean, it comes from the use cases themselves, because the data is onboarded by the teams. There is not that much noise in the data itself. It is also segregated. We have the personas. And also, I mean, when it comes to providing the answer to the user's query, we provide the fact-checking tools like links and source text and so on. So this kind of mitigates the risk of having polluted data. But I mean, on that matter, we are trying to do some a nice update for Project Sherlock, and we hope to be able to find a way to deliver this. It's about not So right now we rely on centralizing the data, so processing all the documents that come in and storing them into different buckets, indexes for the use cases. But we want to do an update where we are not required to do that. But this is like a whole different approach, and it requires a lot of effort in terms of processing the documents, seeing which ones are related to themselves, and basically detecting the use cases automatically. And that's going to involve a lot of research. But if we get this up and running, we would be more than happy to share it with everybody and with the open source in the open source community.
Okay. Yeah, one of the things, so we talked earlier about that you're providing kind of the links and sources and stuff, which is great. I guess the follow on though is just, is someone checking them? Because again, most people, if I just give you links and sources, then it's I don't know. It's like if you just carry a clipboard and look good, then nobody's going to ask you questions. So in that same vein, if I give you a response and I provide links and sources, a lot of people will just take that as, oh, it must be true, otherwise there wouldn't be links and sources here, and not actually follow through. So like, is it anyone's job to actually like check those and be like, all right, yes, those are true?
We have been in a closed beta with our teams since the beginning of September, right, Radu? And we have been checking the links ourselves. They have been checking the links and the source tags themselves. We are making sure that the model does not hallucinate. That's super important for us. And we already spent 1 month of prompt engineering to get that. I think I already said that. To get that up and running. And yes, it's very important for us to be sure that we have the correct facts provided by the model and correct references. And we are kind of at 100% accurate with those references and codes. We are not really consistent with the answer. Sometimes, we get an answer like, yes, this happens, and the coded text says, no, it doesn't happen. It's not like that at all. And that's that seems a little harder to resolve somehow.
Okay. You touched on just a minute ago, you touched on some things that you're kind of working on or whatever, but like, are there any other things like on the horizon or other what's the vision, the future vision for Project Sherlock?
Radu, you want to take this one?
Yeah, so as Tibi already mentioned earlier, there are efforts that we are making to make the project open source, or at least the core concept of the project. We also want to extend our way to communicate with the teams by also having a Teams bot. And in terms of actual improvements on the bot, here is a broad scope. I mean, there are so many things that we can try and do. One of them is actually trying to get the bot to execute actions, right? So to execute code scripts, because right now, and this was very interesting to see, when we're retrieving the documents, we're using like keyword-based search and semantic similarity search, and the idea that they work good, we combine them together. The thing is that if you retrieve the wrong stuff, the model will perform bad. So I can say that it's basically 70% the way you retrieve your data and 30% the answer itself, right? Because if you retrieve the data in a good format, the answer would be good. So there was an interesting question that was asked on the reports channel. Tell me about the attacks that happened in the past 6 months. So how exactly will you retrieve the documents that contain that information? Because if you do keywords search, you'll only get months, 6, so on and so forth. If you do similarity, you'll only get documents that are mentioning some sort of temporal context, right? And then we were thinking, what if we can infer filters on the query, right? So have the LLM take some filters that we can apply on the knowledge base. So it was pretty accurate in generating those filters. So now it's like a 2-step process. First, we filter the database in order to reduce our space of search, and then we use the query to search the documents that we know for a fact that are now in the parameters of the query. So if you can do that, why not simply generate a function call, right? So you have your own scripts that are written and internal, and then the model should actually reason on the query and trigger just a script call. And then take the output of the script that will be executed internally. I mean, we don't actually generate code with the LLM because that's not that feasible. And then we use that output to further answer the user query or perform the instruction.
All right. All right. I mean, I think it was a good conversation. It sounds like an interesting project. It sounds like you guys are. It's an interesting project, and it sounds like you guys are approaching it the right way. Because again, I've had many of these conversations this year with various vendors and practitioners in terms of generative AI and large language models, and like everyone is doing it. Everyone's trying to work on it, trying to figure out, well, how do I make use of this to streamline things for our products, for our customers, et cetera. But there are all those challenges that we talked about in terms of the data set and the hallucinations and the making sure the results are correct and stuff. And so, it sounds like you guys are addressing all of those issues, and it seems like a promising project. So, I mean, you can either of you are welcome to share any final thoughts, but otherwise, I just want to thank you for taking the time.
Yeah, one final thought from myself is that for now, like the level in which we are in generative AI, we need to think of assistants as assistants and nothing more, right? So we still need to be in control of what happens, because you cannot actually 100% rely on the output of a generative model. You can just try to get it to help you get a better direction, right?
Yep. Makes good sense. All right, guys. Thank you.
Thank you. Thanks for having us.
I appreciate you investing your time to listen to the podcast, but I also invite you to engage on social media. Please go like our Facebook page and follow @TechSpective on Twitter and Instagram. You can feel free to let me know what you like, let me know what you don't like, let me know if you love it, let me know if it sucks, and let me know what products you'd like to see reviewed or what questions you'd like to see answered in future posts.